in exam, you'll find this very common experiment finding the acceleration due to gravity or acceleration of a free fall. It can be done in multiple ways. Like you can use a meter rule and a stopwatch. You can use light gates. You can also use a tap switch to work out the acceleration due to gravity. How it can be done? Um, so in the question, you're asked to determine the acceleration of a free fall at the surface of the Earth using a free fall method in the lab. Describe an apparatus you use and the measurement you will take, and explain how would you use them to determine the acceleration due to gravity or value of the g. So one way is we'll drop an object from certain height, we'll measure the height from which the object is dropped. So what we need for this, we need a meter rule and we need a stopwatch, and we'll determine how much time it will take. So we'll determine the displacement, the S is there, and T, and we change the position like we drop from different heights, and we'll determine the time it will take to fall. So if we determine, so we need a meter rule and a stopwatch here for this. So we'll place the meter rule exactly vertical and determine the distance from which the ball is being dropped. And the moment we drop the ball, we'll start the timer. And once it hits the ground, we'll stop the timer. And then we'll change, because whenever experiment is done, we must repeat the experiment. So we'll repeat with different positions. We'll drop the ball from different position. And we have this equation S is equals to ut plus half at square, the equation of the motion. But this equation will be modified whenever object is dropped from certain height, so initial velocity is 0. So as its initial velocity is 0, so it will be S is equals to, as initial velocity or u is 0. So u multiply, like 0 multiplied by t, so this will be 0. So this will be half, and acceleration is due to gravity for the falling object without air resistance. So this will be g and then t square. So what we will do to determine the acceleration of this object due to gravity, we'll plot a graph between the displacement on y-axis and t square on x-axis. So when displacement is on y-axis and t square is on x-axis, what will be the gradient of this graph? The gradient of this graph will be equals to half g. But if I want to determine g, so the gradient times 2 or twice of the gradient will be equals to g. So you have to write this, you have to plan this experiment. So the points which you will include, you'll mention, will measure the distance and how it can be measured by using a meter rule. Then you'll mention, we'll measure the time by using a stopwatch. Object is dropped from certain height, we will record the time it take to hit the ground, and repeat the experiment with different positions, and we'll get a different value for the time. Plot the graph between S on y-axis and t square on x-axis. And the gradient will be equal to half g, or gradient times 2 is equals to g. So this is one way of finding the acceleration due to gravity. We can also modify this experiment. How this can be modified, like example, here, because we are using a stopwatch, so there is an error due to reaction time. So what it can be done to reduce this error, we can use a camera. So using the camera, we will record the motion of this ball. What is the advantage of this camera? Like using a camera, like we can repeat, like it can be playback. That is one advantage. A second thing, how to know how much time it will take from the point where we drop till it hits the ground, because every camera is having a frame per second. So every camera is having its resolution or the frames per second, like how many frames it can take in 1 second. So the frame per second for the camera multiplied by number of the frames. How many frames are captured? So this will give us the total time. Like using a frame per second, in 1 second, say 20 frames are there. So if we have 50 frame, that will be x second, and we just cross multiply to determine the time. So using frame per second, we can determine the time. That will be more accurate as compared to that of stopwatch. This experiment can also be done in another way. Like here we determine the displacement and the time. But what if we want to determine the like we want to find its velocity? So the same object, an object is dropped from certain height, and this time we can have a light gauge at the bottom. So the light gauge, the light sensor are placed at the bottom. So using a meter rule or the meter scale, we determine the height from which this object is being dropped and how the light gauge will work. So when this object will fall, how much time it will take to interrupt. Like using the light gauge, we can determine its speed. How we can determine the speed at which the ball or the object is falling. So measuring this length or a diameter, basically if it's a spherical object, we'll measure its diameter. If it's a cylindrical object, we'll measure its length. So after measuring a diameter by using a micrometer, we measure its diameter, say d, and these light gates are connected to data logger and then interface to computer. So directly, this will give us the time the light gates are interrupted. So we'll have the time and we have the length of the object, or in this case, we have a diameter of an object. So length of an object or size of an object divided by time for which it interrupt the light gate will determine the speed. Initial speed is always zero because falling object's initial speed is zero, and acceleration is due to gravity. So we have this equation 2as equals v square minus u square. So if this equation will be modified as 2gh is equals to v square. Or if I write the equation v square is equals to, like the same equation I'm just rearranging, v square is equals to u square or 2as plus u square. Because the initial speed is zero, so initial speed is zero, so it will modify as v square is equals to 2gs. Now we compare with the equation of straight line y is equals to mx. So on y-axis, if I plot v square, on x-axis, if I plot the displacement, what will be the gradient of this line? The gradient of this line will be equal to 2g. So in this case, the gradient is equals to 2g. If I need expression due to gravity, so gradient divided by 2 is equals to g. So we can also use the light gates. Instead of using a stopwatch, we can use the light gates. That will be more accurate as compared to that of stopwatch. But the problem, the difficulty here, as we need the power supply for these, or like whole system is needed. Light gates alone will not work. We need light gates, then we need data logger, and then the computer to connect and get the results. So we need the whole setup for this. So that is a drawback of this procedure. But the advantage is that it reduces the reaction time when we are using a stopwatch. So comparatively, it's more accurate as compared to the previous method in which we use a stopwatch and the meter rule. So this is also another method to determine the acceleration due to gravity or acceleration of a falling object. There is also another method which can be used. In that case, we use an electromagnet. As you can see here, this electromagnet is interfaced with a timer, and there's a trap door switch is there. Now what happened as the initially it's an electromagnet, like the current is passing, so initial speed is zero. For falling objects, initial speed is always zero. This is an electromagnet. The moment we will stop the current in the electromagnet, the timer will start. As the timer start, the ball start to fall. When this ball fall and hit the trap door, this will break the circuit. This trap door will change the position. Like initially it was there connected, so it is connected to the circuit. But the moment the ball hit the trap door, it will break the circuit. So when it break the circuit, the timer will stop. So that is the time taken by the ball bearing to fall from certain height edge. So again, we have the time, like we'll change the position, we'll change the height, like we'll draw from different height and we'll get the time it take to fall. And we have this equation S is equals to ut plus half at square. As the initial velocity is 0 and expression due to gravity, so it will become S is equals to half gt square. Then we compare with the equation of straight line y is equals to mx. So on y-axis, we have the displacement from which the ball is being dropped. On x-axis, we have t square. So what will be the gradient? It will be a straight line through origin. The gradient of this graph will be equal to g by 2, or gradient times 2 will be equals to g. But the difficulty in this, like the source of error in this experiment, as this ball bearing is there, when we switch off the electromagnet, instantly it will not fall because it will take some time to demagnetize. So the moment we switch off the supply, the timer will start, but the ball does not fall. So we'll get an extra fraction of a second more as compared to actually the ball take to fall through this distance. So this is one source of error. The another, if a ball is dropped from greater height, so it might reach a terminal velocity or its acceleration may not be constant. So ball should not drop from a greater displacement. As a result, more air resistance, which can cause this ball to reduce the acceleration. So its acceleration won't be constant. But accuracy in terms of, as it reduce the reaction time due to a person, as there's no reaction time involved here, we don't, like, it does not take it, we don't have to record the time by ourselves. The timer automatically start and stop, so it will be more accurate as compared to that of stopwatch. So there are multiple ways to find this expression due to gravity. Then give one precaution you would take to ensure the accuracy of your measurement. Like what precaution we should take? The precaution should be related to experiment which we plan. Like example, if I'm using a meter rule and a stopwatch, so we should avoid a parallax error, look perpendicular. Like if the experiment was done using the meter rule and the stopwatch. So this is a meter rule. So when we are reading the length, when we are reading the scale, we should always look perpendicular to avoid a parallax error.